Our next speaker is actually coming forward from this afternoon because we are missing a speaker because he missed a plane, but he'll be here in the afternoon. And now we're going to hear from Dr. Pooran Gaur from ICRISAT, chickpea breeder, talking about chickpeas in water-limited environments.
Good morning. On this presentation, I'll give you a highlight of ICRISAT, what ICRISAT is doing with the partners for breeding chickpea varieties adapted to water-limited environment. And so if you see, chickpea is grown largely in the dry season up to the rainy season on residual moisture, and usually it uh, experiences terminal drought at the end of the season, and in some areas it is coupled with also reproductive stage heat stress. And we see that these are increasing continuously because of the climate variability in terms of rainfall and fluctuation in temperature. And we see that uh, the genetic options we have is developing early maturing varieties and also drought and heat tolerant varieties. So coming to the first, strategy which is largely being used is development of early maturing varieties. And here in this area, I will say that excellent progress has been made in chickpea in both in terms of developing early varieties with high yield potentials in this case. Now, in recent years, very much development has been taken place in terms of understanding the genetics of earliness. We now know that there are at least 4 different non-allelic genes for earliness. So you can deploy any gene if you want. They have almost similar effects based on the linkage relationships. And also, when we try to map them, we found that it resembles very well that the major QTLs, they are in different regions. So this provides us opportunity of very precisely manipulating earliness in chickpea. And coming to the drought tolerance, the most common method which we have used in breeding is evaluating the breeding material under drought stress conditions, or I will say rain-fed conditions, where you don't irrigate the crop. And in this environment, you get the moisture stress at the end of the seasons, which has been very largely successful. Limited efforts have been made in breeding using the specific traits for drought tolerance. But in recent years, we have worked on a lot on the root traits in chickpea. We started from root traits, develop mapping populations. You have seen this earlier. Raju Varshne has presented it earlier that this mapping populations, we were able to identify one QTL hotspot or a genomic region which control many traits, not only root traits with other traits. In recent years, what I want to say is that in recently, our colleague Vincent Wada is physiologist, looked again at that mapping populations, and he looked for some vigor traits, including leaf area, plant height, and growth rate. Again, in the same regions, you are getting that. So this is the genomic reason, which not only the root traits, but it in fact controlling the vigor in this in case of chickpea. So what we did is that we have moved this genomic region to many of our leading cultivars, and here I am giving examples of only 2 leading cultivars, JG11, which is here in southern India, most promising, and ICCV 10. And you can see that some of the lines are now moving forward after several evaluations. They are in national trials in India. 3 of them has moved to advanced trials, and then a new trial has been formed, which is for these interrogations lines, and these within 2 years, some of these will be released for cultivations. And now another thing which I want to emphasize is the heat stress, and you'll see that in many of the environment where chickpea is grown, chickpea is faced with reproductive stage heat stress. There has been a lot of work in recent years and very good variations for heat stress. In the same field, you can see that the sensitive lines, which produces only flower, and you have a tolerant line which has got good pods. And if you see the extremes, these are the extreme cases where you have highly sensitive and tolerant line for heat stress. And we have used a very simple method. We have standardized for heat tolerance screening, where you have the normal crop season, you grow here, where the temperatures are usually lower than 35 degrees Celsius, but you can grow late planting or summer planting, where you always have temperature above 35 degrees Celsius during the reproductive stage, and you can screen for that. And now this is in the mainstreaming our breeding program. The lines which we are identifying in normal season, we are screening them in heat stress every year now. This is mainstreaming now. And the simple trait which we are using, you can see the kind of variations you get for pod sets. And very simple trait is the number of filled pods per plant. You can use as an index for selections for heat stress. You can see here, these are the plants you can select. And what we found is that, the breeding lines we are developing at Patancheru here at warmer regions, most of them, they turn out to be having very good level of heat tolerance. And in recent years, we have been able to map two major QTLs for heat tolerance. You can see these are the parents of mapping populations we have developed. You can see there are two major QTLs, one on linkage group 5 and another on 6. We have been able to map them, and these are being validated now. Another approach has been very successful in combining drought and heat tolerance is these magic populations, where we use the 8 parents, cross them in all possible combinations, and we develop the lines and the populations, which have given us a lot of good materials and some combining drought and heat tolerance. So if you see that in case of chickpea, the impacts of developing short duration varieties with having better drought and heat tolerance. This is the situation in India, where you can see that chickpea was earlier in the cooler regions, northern India, but because of the green revolution, about 4 million hectare area got reduced here. But because of the availability of short duration varieties and the drought and heat tolerant varieties, about 4 million hectare area increased in central and southern India. And you can see that even the southern India, where chickpea was not a crop, actually it was a minor crop, you can see a revolution here that the area, production and productivity all increased, and now southern India is leading chickpea producing regions in India. Similarly, you can see the Myanmar, where you can see that these 4 varieties, short duration varieties, presently cover 96% of the area in Myanmar. And Dr. Siddiq will be happy to see that, 88202, which is he released a SONA in Australia, is covering about 17% area in Myanmar. Heat tolerant variety Yejin 4 is covering about 20% area. And you can see that, these within 15 years, about the product area has doubled, productivity has doubled, and the production has gone 5-fold in Myanmar. This is the impact of short duration drought and tolerant, heat tolerant varieties. Just finishing. Just you can see that in recent years, the development which have taken place in understanding the genetics of these traits, precision phenotyping, genomic tools, and rapid generation turnover. I didn't touch on that, but we are able to take 3 generations per year comfortably in chickpea, which have really enhanced our efficiency in developing breeding lines, adapted to water stress environment. And then early maturing varieties with improved drought and heat tolerance have helped in expansion of chickpea area to the short season environments like semi-arid tropics. With that, thank you.